Guys, so this is part zero. Um, the reason I'm making a part zero is because I accidentally forgot to explain how you're supposed to set up your programming environment and just jumped to first program with the sprite. And some people were worried, and some people were having trouble understanding how to get from here to this, your sprite in the corner. So the first thing you'll always need to do is copy your equates, all of these. I'll make this available in just a blank file with this. Now, the reason for this is that you need to define your not all 64 of your registers are needed, but you have 64 hardware registers located from hex 0 to hex 3F. This first half is TIA registers, so that's your sound registers, and the second half up here is your graphics registers. So our 6 audio registers here, another 6 for our buttons on the joysticks, and then all of these. Now these the P0C1 through P7C3, these are your color registers. You have 25 of them, and each one is 8-bit, so 4-bit luminance and 4-bit color value. And then you have a 25th one, which is called background. Now you're gonna immediately notice this clicking noise, which is always why I always like to start my program with my CPU vectors. What this will do is, and just to make sure that I did it right, yeah, I did not. Um, you also need this. This is for NT. I believe it is different for PAL, but I don't know the PAL BIOS, so I cannot confirm that. So first off, now that we have our zeroed out audio values, we won't hear that clicking. If I remove it, we might hear clicking. In this case, we don't, because 8-bit workshop won't randomize your hardware register values. It'll always be what it was left there previously unless you change it. So if I do LDA, I can change the background color, and it can be any of the 256 colors that we have access to. There's no sort of limitation like on the Commodores and the VIC-20 and all of that, where you could only have 16 colors. There's you have the full access to 256 colors. So to show you what different hues look like, this is what the 16 different hues look like. Um, and of course you have your 16 luminances. It's actually one of my arguments about why the 7000 is the most powerful 8-bit console, is because you have 256 different colors. One of the features it gives you as well is you'll see this pokey here, and on a stock console, you actually don't have a pokey. Um, That we'll get to that later in the sound video coming next. Then you'll see these four registers, switch A and switch B. Switch B's are console registers, so select and start. We actually have a few more buttons. Again, this is why I don't recommend using 8-bit workshop if you're an advanced programmer. We still have the difficulty switches from the Atari 2600, and we also have a pause button, which isn't here either. Again, it works just like before. Our pause button is just a color black and white switch from before. So if you press the pause on an Atari 2600 game that's from like the early 80s, late 70s, like Pitfall, it will actually go into black and white. Later ones just used it as a pause button or something else. But all of the late 70s and some of the early 80s, you will see that you can change the game to black and white by doing that. The second area of your code is you're going to want to do this, and this will reset your stack pointer. So if I do this, we'll see back in our memory browser, everything's 0 except this one FF here, and you'll know you did it right if it shows up there. Versus if I do this, now see our value is still there, but now we have this other value over here. So we'll also need to reset our stack pointer. And of course, we need to store this. We need to store this here because if we don't, um, our our left and right buttons will just show up as one button. Again, this is for compatibility. So if you were to make an Atari 2600 game, you need to be able to have it work on the 7800 because again, that was one of the key selling points is that it can also play your 2600 games um using a 7800. It's something the 5200 cannot do, which is kind of ironic because as we just saw, the 7800 is much different than the 2600 or 5200 or even the Amiga. Because yeah, the Amiga is actually just a 16-bit Atari 5200. Um, Input control, this register is next. Um, Now this is why I like to copy over code and not just do everything from scratch again because it's kind of cryptic what you exactly need to do. So this code, we need this code because obviously it's the RAM clear, and you actually don't need this first part. Um, you just do this, and I like to keep it in order. The reason it was out of order in the previous video was because again, it turns out that if you go to a previous game, it wasn't clearing those 128 bytes of RAM. So you still had that RAM not being cleared. There's actually a second thing. The thing is, it's not shown here, but the TIA RAM is actually accessible at hex 400 to 480 to 4FF. So you would still have your 128 bytes of Atari 2600 RAM. Um, so the second thing you need to always do is your have your Atari 7800 mode lock in place. Again, it is not emulated correctly here, but you in place. If you don't have it in place, you might boot up into 2600 mode. Of course, your flash card should be able to detect if it's a 7800 game or a 2600 game, but if it doesn't do that, then it might boot up. But if you were to make this a real cartridge, for example, and you don't have a flash card to boot up for you, it wouldn't do this, and you might boot up into 2600 mode. Um, Another thing I like to copy over is, of course, I'll set up from before. Obviously, you need your clear audio registers, but this stuff, you really just need this everywhere. Like, you're never going to, have, have a situation where you don't use a DLL, because DLL, like, see, there's nothing here. Now, I don't know what this is. It might be a glitch of 8-bit workshop, but I can't confirm. Um, for now, I'm gonna assume it is because no DMA goes on these bottom 22 rows. 22 rows. Because this is the only actual area where Maria won't output anything if you don't tell it to. So like 8-bit workshop will output the full 320 by 240, but a normal TV would only really output 224 lines. If you want, you some can adjust. Like if you have a computer monitor, you can adjust it. But I only like to use 200 lines, 192 for the main gameplay area, and and 8 more for score. You could so like 192 lines for your main gameplay area, and then there you see the space up here. This is I believe it is yeah. Um, you have 16 lines of nothing. And the reason you have nothing is because again, it comes down to the fact that overscan is a thing. Again, you can adjust your screen, but I don't recommend doing this because you don't know if the consumer can or not. You're the producer coding the game. You don't know if they can or not. So one of the main things, and as you can see here, we don't have our um pointers, which again, you really should just have these everywhere. Don't change it unless you really care. Like as you'll see later, and of course we need our blank DLL. Yeah, right. Um, hmm, I don't remember doing that last time. And of course we need our DLL space. Strange. But you always need this. I'm not sure why it's saying data too long, but yeah, oh right. Yeah, you need save code. Strange. Yeah, if you don't forget, yeah, don't forget your say code down here. Otherwise, 8-bit workshop might yell at you. Again, it's one of the things I don't actually like about this tool. The second thing is that you'll see up here your files and your consoles. Console, you can switch between all these different consoles. So like I have all my it's Sears Time games down here and and all that. Um So you can actually do other consoles here, which I plan on getting. We're gonna focus on the 7800. And yeah, it is yelling at me because my code is too long, but move this and it shouldn't do that. So if it tells you that your code is too long, just ignore it. And maybe get rid of the ds.b. Why I like copy over stuff. The final thing we need to copy over, that's why. You need to have your, so now if I do, now it doesn't yell at me. 64. And the reason you want this, again, it's compiler specific stuff. So if you're using a different compiler for whatever reason, or you're choosing not to use 8-bit workshop, you won't have these problems. But but the reasons why you do want 8-bit workshop are beneficial. Um, and again, if when you're making a game, these 8 palettes, you will be able to use these freely. Like on the NES, you have limitations where you can only have 4 palettes for the foreground and 4 for the background. Not so with the Atari. All 8 are global. And that's because there is no background. It's only sprites. Um, Another thing you will always need is DL space. Um, the most you're ever gonna want for a single DL is having having 128 bytes per line. Any more, and really, it just gets unnecessary. Like, even if you're doing a sprite background, which you would need 21 sprites, quote unquote sprites, per zone to emulate that background feature. We'll get to that later, by the way. Um, in the graphics video. Um, it's just unnecessary. So the other thing you're always gonna want to do is back to SIGU data. This is our fast RAM. Our fast RAM, and of course our stack. But all of these values, um, these are your hardware registers. These work exactly the same as your Atari 2600 hardware registers. That do the same things. Your joystick, your console switches, and your I/O control. Um, the other thing, this is important by the way, is remember that we are literally using the Atari 2600 chips for this. So when you access these chips or these chips, your CPU is slowing down to 1.19 megahertz. And and that's not a big deal, but you will never want to write to these more than you ever have to. So I like to actually shadow these. It wasn't shown in my original video, but I like to always have shadow registers for these. Because again, if you don't, then you're slowing down, and it'll also cause conflicts. Like if one sprite writes to my audio registers or even external audio registers, these, by the way, your CPU doesn't slow down when you write to these. Um, but I don't want to slow down all the time to write to these or read from these. And same goes for the inputs, by the way. Those are also controlled by the TIA chip, and you will also slow down. Same for the directional inputs from the from the joystick. And by the way, I believe this is not confirmed, but I believe you actually still have access to the timer registers of the PIA, just like you do with the Atari 2600. However, I haven't found a reason to use these in my 5 years of coding for this console, so I would just ignore them. Um, and of course, the final thing you would need after this, then you would just go to part one. So if you're at this point and you can change your color of your screen, like for example, if I could do like if I want to do an example program, we'll get to WSync later, but WSync again works just like it did on the 2600. You'll stop the CPU, it will stop doing what it's doing until the end of a scan line. So if I want to make a program like this, um, so I can go do something like this, and we have our little gradient. And any Atari computer you can do. It's not a 7000 specific trick. Um, if you want to synchronize it, um, right, synchronize it using this interrupt. And we can actually change where this interrupt is, which we'll get to later. But if you're here and you can do this, then your environment is set up correctly. And of course, just get rid of this, and then we'll also get rid of this. Yeah, get rid of this. Once you're here, go watch part one.